Hello everyone. Today I'm going to explain about my MHF4U Unit 5 mid-unit assignment. So let's get started. So first of all, the first question is determine an equation for the family of quadratic function with these roots. So we have to create a type of equation with these given roots. So for the first question, write equation for two functions that belong to this family. So first of all, I equal this one to this f of x, and here, and you have to rearrange it into this. So basically what I gonna do is like that, like this. Minus 5, imagine x is equal to minus 5 by 2. So the formation of so when we form factors, the factor would have to be 2x plus 5. That's exactly what we get. And then we get all these four, and by this method, we get all these four factors, and we have to put one constant in front of it. And then for a, we have to choose this type of equation so that we want to choose one random constant. It could be either, minus 3 or minus 3 or minus 3. So you should have paired with the same number, but of course with positive and negative, different positive and negative value, so that the graph could be compared whether or not, in order to check whether or not it becomes directionally opposite. So here I do it, and by multiplication with minus 2, so I get this equation. And for 2, I get this equation. And that's all for A. And for B, I do here. And this gives the point of minus 2 and 25. This coordinate, by this coordinate, we can apparently get this evidence of this value. But x would be minus 2, and f of x, of course, would be 25. So by substituting this value, we get the value of k, constant. So k is minus 5 by 11. So f of x would be this, minus 5 by 11, and these four factors. So after C, so by C, we have to draw the graphs, of course. As you can see here, the positive value graphs of 2, with constant value 2, is facing upward. So we could say like it has like W shape. For the negative graph, you can see it has M shape, which means like it has open down parabola, and it is facing downwards, of course. So this would be the this one, 2, minus, and this would be, of course, our newly obtained value of minus 5 by 11. Here you can see here it becomes a little shorter because of its smaller scale. So that's all about my number 1. And moving on to number 2, we get here the distance. We have the distance d in kilometer traveled by a plane after t hour can be represented by this equation, and it has interval, and how long does the plane take to fly this 4088 kilometer. So it basically gives the distance. So d of t would be 4088 kilometers. So we equal it, and we finally got the equation of 4088 equal to minus 4t2 plus 40t squared plus 500t. So here we get this equation, and then we use and of course I use calculator, and here the factor becomes simplified, and then we get 3 type of answer. So here let's look at it, which would be the plausible answer. So by here, it says the value, it says the interval of, so the value of t would have to be between 0 and 10. So minus 10.0 is far beyond and far smaller than 0, so we have to reject it, of course. So the period, since the period of course couldn't be negative, so this is really, so this is obvious. And then moving, and then about t is equal to 13.7, it is of course again beyond the interval and greater than 10, so we have to reject it. So the only plausible answer would be t is equal to 7. So the period is t is equal to 7. So this is my number 2 solution. And moving on to number 3, we get here. Write an equation for a rational function where graph has all the indicated feature. It is x-intercept, y-intercept, vertical asymptote, and horizontal asymptote here. So I first basically do it here. So x-intercept would be x at, which means like the graphs or the line or the curve would cross the point of x equal to minus 4. So the numerator must be, of course, x plus 4. So basically what we do here is that we move minus 4 into the left-hand side of the equation. So we got the factor. And then since this x-intercept would be the numerator, of course, this type of equation would be by fraction. So, and then we do it as usual here. So y-intercept would be y is equal to 0, and of course x, so of course y, and I forgot to tell is here that x is equal to minus 4, so y would be 0. So the value of x would be 0 at y is equal to minus 2. So the vertical asymptote would be x is equal to minus 2, and the denominator, of course, must be x minus 2. So this would be here. With, of course, we haven't done solving yet, since we have to add another factor here. This first assuming that this radical function here. So I first put this function of around f of x equal to px plus 2 by bx plus c, so the horizontal asymptote, and then I equal it to p by b equal to 1, so p would be b, p is equal to b, so it would be 1, of course. So here, moving on about the vertical asymptote here, this would be b x plus c is equal to 0, so finally we get the expression of c is equal to 2b. So the vertical asymptote is x is equal to 2, so c would be 2, c would be equal to 2, and b would be equal to 1, of course. And so by having this here, this expression here, we get here. So as we have already have it here, so the value of p would be basically 1 would be equal to 1, so p is equal to q. So the coefficient, so the since the horizontal asymptote is of course y is equal to 1, the coefficients of both numerator and denominator must be the same, which means like p and q would have to equal to be 1. So the final equation is f of x equal to x plus 4 by x minus 2. So the points obtained, of course, we have to prove it. So here I use one coordinate, I put it here, and then f of here is equal to minus 2, which basically equals with this coordinate. So this expression satisfies all of the given conditions, though the universal equation of f of x for this type of question would be x plus 4 by x minus 2. So that's all about my work on MHF4U Unit 5 unit assignments, and I hope you really enjoyed, and thank you.